As we saw earlier, the instantaneous rate of change, or the derivative of the revenue function, gives the marginal revenue function. When we're talking about marginal revenue, if R equals R of X is the total revenue function for a commodity, then the marginal revenue function is MR bar equals R prime of X, or the derivative of the revenue function. And if you didn't know, a commodity is usually something that you sell. It could be a service or like a product or an item. Recall that if the demand for a function for a product in a monopoly market is P equals F of X, then the total revenue from the sale of X units is R of X equals P times X, which is equal to F of X times X. Example 1 says, if the demand for Mr. Kwan's ab blasters in a monopoly market is given by P equals 14 minus 0.02x, where x is the number of units and P is the price per unit. Part A says find the total revenue function, and Part B says find the marginal revenue for this product at x equals 50. So let's start with part A. It wants us to find the total revenue function. And because we are in a monopoly market, we want to use this formula here. We know that the total revenue function is equal to P times X, which is equal to 14 minus 0.02x times X. And if we went ahead and simplified that, we would get 14x minus 0.02x squared. So I'm going to go ahead and box our final answer for our total revenue function for part A. And for part B, we want to find the marginal revenue for this product when x equals 50. So the marginal revenue is the same thing as the derivative of the revenue function. And that is going to be 14 minus 0.04x. And now what we want to do is we want to evaluate r prime of 50. So we're going to plug in 50 into our derivative function. And that is going to simplify to 14 minus 2, which ends up being 12. And remember, the units for this is dollars per unit. And basically what that is saying is that the revenue gained from selling the 51st unit is going to be approximately $12. Now, let's just quickly look at what the actual revenue gain from selling the 51st unit is going to be, because remember, this 12 here, the $12 is just an approximation. But if we calculate R of 51 minus R of 50, that will tell us how much we actually gained from selling the 51st unit. So R of 51 is going to be 14 times 51 minus 0.02 times 51 squared. And then we're going to subtract off R of 50, which is 14 times 50 minus 0.02 times 50 squared. And if we simplify that, R of 51 is 661.98, and R of 50 is 650. And so the difference between those two values is $11.98. So it was a pretty close approximation. This is our final answer, but this was the actual revenue gained, and it's pretty close. It's just 2 cents off. Example 2 says, refer to the graphs shown below with the revenue function and the marginal revenue function. Determine where the revenue function has its maximum. What is happening to the marginal revenue at and near this x value? So here on the left-hand side, we have the total revenue function, and it's asking at what x value the revenue function has its maximum. So this is the graph of a parabola, and the maximum is, depending on whether it's facing up or down, it's going to be at its vertex. So this is a downward facing parabola, so the maximum will be at its vertex. And so if we look at the x value at the vertex, the x value looks to be 400, and the y value looks to be like maybe 3100 or 3200, but it definitely looks like the x value is at 400. And there's actually a way that we can algebraically show that. So let's do that really quickly. I have the function 16x minus 0.02x squared. And if I factor it out in x, I'd get 16 minus 0.02x. And if I set both of those equal to 0, from here, I would get x equals 0. And then the other equation, I get 16 minus 0.02x is equal to 0. And if we solved that, I would get x equals 800. If you plug in 800, that's going to give you 0. So the vertex is going to happen exactly halfway between 0 and 800, and halfway between 0 and 800 is 400. So that's kind of how I could quickly show that algebraically, that this is in fact 400. So that was a very long-winded way of saying that the maximum is happening when this company is selling 400 units. Now it's asking what's happening at the marginal revenue at and near this value. Well, the marginal revenue at 400 is equal to 0. So MR of 400 is equal to 0. And then basically, as you sell more units after 400, the marginal revenue starts to become negative. So as x becomes greater than 400, the marginal revenue starts to become negative. What does that mean? Well, that means that the total revenue function is going to be decreasing. So if there's negative happening here, that means that after 400, the total revenue starts to decrease. And so if you were maybe like a financial advisor for this company, you might suggest that, 400 is kind of the sweet spot, and that's what's going to get them the most revenue, is producing and selling 400 units. And we're going to go into more detail in a later section on how to use calculus to figure out what's going to provide the maximum revenue. But for now, we'll just leave it at that.